Hello and welcome again as we consider yet another multiple choice question for IB Chemistry. Which ionic compound has the largest value of lattice enthalpy? And here you have these four choices. Now, the term lattice enthalpy is defined in different ways in different sources. But according to page 16, section 18 here of the IB Chemistry data booklet for first exams in 2016 and beyond, it says that the lattice enthalpy value, represented like this, is the enthalpy change associated with this process. An ionic compound AB in the solid state going into its constituent ions, A positive in the gas state and B negative in the gas state. The idea with this lattice enthalpy is that you have to go from the solid to the gas, because to remove that attraction, that electrostatic attraction completely, you need to separate these constituent ions, and to do that to a satisfactory extent, you've got to get them into the gas state to get this complete separation of this electrostatic attraction between the two ions. So lattice enthalpy, solid ionic compound going into its gaseous ions. Now, the question is not asking you to define lattice enthalpy. We just decided to do that for the sake of the learning and to know what the term is. Now, this lattice enthalpy in all of these cases is involving bond breaking. Bond breaking, of course, requires energy and it is endothermic. You're breaking up this lattice from that solid structure into these constituent gaseous ions. Now, what we need to know to solve this particular question and any similar ones that would come in the examinations is that the two factors to consider that determine how strong this electrostatic attraction is. And the first one to consider is the amount of charge. But here magnesium, which is Mg2 positive, is 2, and sulfur, which is S2 minus, that also is 2. So the product of those charges is 4. So this is quite significant. You do the same calculation here and you'll also get 4. And here you have calcium with its 2 positive charge attracted to one Br negative and then another Br negative. This would be weaker than these two. And then of course positive 1 and negative 1, this would just come to 1 multiplied by 1 equals 1. So there's a much stronger electrostatic charge with A and B. And even if you wanted to consider C as part of that, you could add it. Then you could look at the next piece of information that would allow you to now arrive at the answer. And to arrive at the answer, you have to look not only at the product of the charges, but also the size of the ions. And Br2, of course, quite large. Calcium is bigger than magnesium, so we can eliminate this. And then now we've got two which are very similar, MgO and MgS. But we're going to arrive at the answer of B because O is a smaller ion, so therefore its charge is going to be more concentrated, and that distance between the magnesium and the oxygen is much smaller. And the smaller the distance, the stronger the electrostatic attraction. So first we look at the product of the charges, and then if we need to break a tie like we need to do here between A and B, then we look at the size of the ions. So because of its small distance between magnesium and oxygen, and of course the 2 positive charge and the 2 negative charge, the answer for this question is B.